versus juxtamedullary nephrons. So I picked this model because it shows you the cortex and the medulla. It shows you these nice medullary pyramids, medullary column, pyramid, column, pyramid. So the blood vessels run up through the columns and they surround the pyramids. And you need those blood vessels because they supply blood to the little glomeruli that are housed in these little nephrons. So here you've got a nephron represented as little white dots on this model. The glomerulus is this region which is surrounded by the Bowman's capsule. Fluid leaves Bowman's capsule, goes through the proximal convoluted tubule, descends into the medullary region as the descending loop of Henle, or the descending nephron loop, curves and comes back up as the ascending loop of Henle, or ascending nephron loop. Then it becomes a distal convoluted tubule and empties into the collecting ducts, which in turn form the little renal papilla that empty into the minor calyces. Minor calyces join together and form major calyces. Major calyces come together and form the renal pelvis. From the renal pelvis, urine, or filtrate, then exits the kidneys through the ureters, makes its way down to the bladder for storage. Now, the question was about the nephrons. Nephrons include the glomerulus and all the little tubules. So, this little nephron, and this nephron, and this nephron, and that nephron, and that one, those are all well established in the cortex. So they're called cortical nephrons. Some of the little nephrons are right at the cortex medullary border, and so those are called juxtamedullary nephrons. About 15% of the nephrons are juxtamedullary, the remaining 85 are considered cortical. 85%, that is.
Do they act any differently?
They do a little bit. The cortical nephrons are your bread and butter for doing filtration and getting rid of wastes. The ones that help to concentrate the urine are the juxtamedullary, because they usually have longer loops of Henle that extend further down into the medullary region. We're going to find out, we haven't done it yet, but in the medullary region you start at an osmolarity of about 300 milliosmoles. That's normal. As you descend, it gets more and more and more concentrated until you're about 1,000 to 1,200 milliosmoles down in this region. So as the loops descend, they're becoming more and more and more and more concentrated. As they ascend, they start to become more and more and more diluted.
Concentrated of what?
Concentrated with solutes. Not water, concentrated with solutes. So as we descend, you lose water,